At least you didn't have to hear what I said. So thank you very much, Toby, for coming to talk with us. So quickly going over his bio, for anyone in the lab who doesn't know him, he is a very active member of our lab. He joined QCR in January 2020. Loves everything robotics and computer vision related. He's had a particular interest in tools that make robotics and computer vision research easier, hence getting involved in RoboStack. Before joining the QCR, he was a postdoc in the personal robotics lab at RoboStack. Before joining QCR, he was a postdoc in the personal robotics lab at Imperial College London, where he also received his PhD in January 2019. His thesis has been awarded the UK Best Thesis in Robotics Award 2018 and the Earl Cadwalder Davies Prize for the Best Thesis in Imperial's EE department in 2017-2018. His works have attracted 2 Best Poster Awards, 1 Best Paper Award, and alongside a bunch of other people at QCR, he has helped win the Facebook Mapillary Place Recognition Challenge at ECCB 2020. And after that butchered introduction, I will hand over to Toby, who will do a much better job in his talk. Thank you, Toby.
Thank you, David. Cool. So as David just nicely introduced me, I'm going to talk about a couple of different snakes today. So probably everyone might have heard about Conda by now, because I'm, whenever there are issues coming up about installing different packages, whether it might be on HPC or on the newest robot in the lab or on Raspberry Pi or somewhere, I'm always like, oh, use Conda. And today I'd like to, talk a little bit more detail on what it actually means when I say use Conda, what advantages and disadvantages it has. And yeah, so let's dive right into it with a little bit of echo. Sorry for that, but cool. There we go. Nice. So what is Conda? Conda is 2 things. First of all, it's a package manager. So, when you run your Ubuntu system, then you often do sudo apt install, and then you add some package at the end. Conda is an alternative for that. So you don't use system packages, you use Conda packages. It's open source, so everything about it, it's basically a bunch of Python or C++ scripts, and it's all open source. It's cross-platform, so you can create packages for Linux, Mac OS, what else is there? Windows, there's Windows, oh gosh. For all those different platforms, as well as for our normal x86 architecture, as well as ARM architectures and PPC and some random stuff, which might not sound very interesting, but if you think about Nico's favorite Raspberry Pi tools, then you need packages which are compatible with ARM. And Conda allows you to do that in a very easy way without even having to think about packaging something for all those different platforms. The good thing about Conda is that it just magically does most of the work for you, regardless of whether you are an end user just trying to use all of those packages which are available, or if you are a developer and actually want to add new packages to Conda, it makes it super, super easy, which is why I really like it. It's language agnostic, so it goes further than pip. So often people use pip install some weird Python package. Pip only has Python packages, whereas in Conda, you can package anything which is Python, C++, R, Java, name it. You can just do it with Conda. So that's another big advantage of Conda over pip, for example. And those binaries that are created by Conda, they run natively on your system. So there's no added layer. As in Docker, you have like a kind of a virtual machine sitting on top of your host machine. And then that comes with all sorts of problems because all of a sudden you have multiple network interfaces that you need to deal with. You need to install your graphics driver. Again, you have like a secondary graphics card somewhere virtually sitting around. That's not the case with Conda. You create executables and they run natively on your system, which is also very nice because it doesn't come with any overhead. So it runs super quick. When you enable all the optimizations, it runs as fast as a executable that is packaged for your system directly. And what it also is, it's an environment management system. So in pip, often people use virtual env, which provides you with an isolation layer. So you have multiple environments, one environment for each of your papers you're writing. That's the way I like to think about it, because in each of your different projects, you might have different dependencies, and working on one of your papers shouldn't destroy your other paper ideally. That's why you like to have isolation. And Conda brings both of you, the package management as well as the environment management. And what's cool about it is that it lives in one directory. Well, if you add the environments in n environment directories, but it can live in your home directory. So you don't, James is always concerned, oh my God, I still have to submit my PhD thesis, and what if the examiner asks me about adding this one new experiment? I can't possibly upgrade my Ubuntu, which I agree with currently. But if you install Conda, it just lives in, you know, /home/James/Conda, and it lives there. And if you delete that directory, it's gone. You know, it only lives there, and it doesn't interfere with your system at all. And what I should have mentioned earlier as well is that you don't need the latest Ubuntu anymore. You can run things on Ubuntu 16.04 and still have the very latest versions of OpenCV, PyTorch, TensorFlow, ROS, if you use Conda, which typically, you know, you need to upgrade your Ubuntu every 2 years, and I can totally understand I was the same. During my PhD, if you want to avoid one thing, it's upgrading your system, because it's going to take you months to get back to your original state if there are revisions for your paper, or even worse, for your PhD thesis. So that's really cool about it as well. What I should have mentioned earlier is that if you have questions at any time, just raise a hand, or online raise hands as well. Scarlett.
When you said before that the Conda lives in like a home directory,
yeah,
where does it live if you're on the HPC?
It lives in any directory. So you can just put it anywhere you like. You can still put it on your home directory on HPC if you are sharing with other people. So in Michael's group, we are sharing all the place recognition things. So we are sharing environments. Then it lives in /work/sci-fi or whatever you are, where you have shared directories.
So does that mean you have to have Anaconda installed like in that folder?
That's right. Yeah. So I can show you in I can show you in a terminal in a little bit where it lives and how easy it is to install in the first place and move around. So you can potentially just move it around to elsewhere if you wanted to, because it's just a directory. The only thing it does, little asterisk there, it adds a couple of things to your bash RC script to automatically load, so you can basically run Conda to start with. So it's 10 lines in your bash script, which it does additionally to creating files in that folder. Yeah.
Peter has a question.
Peter has a question.
There's the microphone on, which I think is that mic.
Yeah? Cool. All right.
You might just need to repeat the questions, Toby, that's all.
Oh, okay.
It's on now.
It's on now?
It's on now? Okay. Cool. So what I just said, this is a graphical version of it. So what is Conda? Conda is it's a tool which allows you to pull out packages and put them into different environments. So environments are your isolated things which you have. You have a root environment, which you get into by default. So you should keep that as small as possible. That's my tip number 1. Tip number 0, because tip number 1 is going to show up later. Tip number 0 is whenever you want to do something, create a separate environment and then do things in there. So I've got dozens of environments lying around. One, if I want to upload a paper on archive and need this one weird tool, which is called Archive Collector. The next one for the work I was doing for PatchNet VLAN, and the next one for the work on event camera stuff, and so on and so forth. So Conda is allowing you to install packages into those different environments, and you can create them with a set of packages to start with, and then you can always build on top and install more and more packages as you go. And the cool thing is, if you know that you have one environment where you installed TensorFlow and PyTorch and everything works super nicely together, and you're like, oh my gosh, how do I recreate that? You just say, oh, okay, let's clone the environment, replicate it, and then install that one additional package where you might be worried that you could potentially screw up something. So that's another thing. Cool. So why Conda and not pip or not Docker? So compared to pip, it allows you to install more than just Python packages. So there are many, many more packages which are written in originally C++ or whatever. Also opposed to pip, it has a smart handling of dependencies. So if you use pip and you install package A that, say, requires NumPy 1.16, then you say pip install package number A, that installs some dependencies. And now in the same virtual environment, you later on, a couple of weeks later, install another package, pip install package B, but that requires NumPy 1.20. So now it just overrides NumPy 1.16 using pip, and your package that you installed 2 weeks ago might not be compatible with that new version of NumPy, crashes, you're wondering why you get this really weird cryptic error about some import stuff, which you can't possibly think about. You can't roll back using pip. It's just a massive pain. Whereas in Conda, all packages they have a core list of packages, and they're pinned to specific versions. So there's just an agreement saying NumPy is pinned to version 1.18. Now, you can always have outliers, but then it specifically says, well, in this particular version, I need NumPy 1.20. And if you now try to install package B using Conda, it tells you, nah, I can't, sorry, mate. That only runs with NumPy 1.16. There's a conflict here that I can't resolve. So it's going to tell you what the conflict is without trying to install it first and then you having to worry about it later. Big asterisk again. That only works if the developer specifies those dependency issues. So if you don't say that your package doesn't work with a newer or older version of NumPy, obviously Conda itself can't possibly figure it out. If you have common packages, there are many, many people reporting issues that say, oh, I was running into that problem where it said, oh, you can't possibly run that with the old version of NumPy. People fix it within minutes, hours at most, and then release a new version. If it's a very uncommonly used package, then you might run into issues. Can just happen. So it's not, it can't resolve issues by itself. There's still, some manual input required, but oftentimes people take care of that. You have the isolation that you also have in Docker. So if you mess up one of your environments, the other ones are still going to work. You don't need to worry about that. And it's higher level when compared to Docker. So Ben, where's Ben? There. Ben, he wrote all those beautiful Docker scripts for Benchbot and was always complaining about, oh my God, now I need this particular thing, but then I need to communicate with the system and the other Docker environment, and it's super, super hard. Conda makes it easier because, as I said before, it runs natively on your system. So you still have access to your, whatever is just above the Linux kernel, let's say, in the case of a Linux environment. So that makes it nicer there. As a developer, if you have a nice, flashy, open source repository, and I'm going to show that later on, exemplified with Peter's repository, it makes it super easy to put up your package. It's a thing, if it's a Python package, and the demo is probably going to go wrong, but I'm hoping to put up a package on conda-forge in 3 minutes, something like that. That's my aim, So yeah, kill me in 20 minutes. That's all right. And there's minimal overhead. It really is. It makes the life easy as a developer. So now let's dive into some terminology. There are different channels in Conda. So a channel is a set of packages that is installable by Conda. So in Ubuntu, you have those PPAs, which everyone hates. In Conda, it's a little bit nicer. So conda is that toolbox that we've seen earlier, that little crane or whatever it was. And then channels are like storages. So a channel offers you to install packages from that specific channel. And if a package is not available in that channel, you might resort to another channel to install that package from that channel. So for example, PyTorch, they have their own channel, so you can install PyTorch easily from there, rather than from the default channel that it comes with. Gavin, you look confused.
No.
No, good.
Very
Okay.
review of conflicts, the same package in multiple channels, does it ask you?
There's a priority list. So yeah, you can set which channel should be prioritized, but let me come to my tip later on, and then that question is going to get, yeah, you don't need to worry about it anymore. So Anaconda is a distribution, so one of those channels maintained by a company called Anaconda. So they have their, big set of channels which is available there. Miniconda is a non-bloated version. So if you download the Anaconda executable, it's like a couple of 100 megabytes. It installs all weird sort of shit that you may or may not need. With Miniconda, it installs Python and a minimal set. That's what you actually need. And then whatever you additionally want to install, you just install via conda install, and that's done. So always go for the mini versions, I would recommend, rather than the full versions. Yeah, but don't use Anaconda. Use conda-forge. Conda-forge is a community-driven channel. So this is like a company sitting somewhere in the US with super great people, but it's just a company. They are, focused on making money, and they have the couple of most commonly used packages, but they are not interested in random package X that we might be interested in. conda-forge is a community-driven channel. So people like you and I can contribute there, can put up issues and pull requests to certain packages. And it contains lots and lots and lots of scientific packages that we might want to use in our everyday research life. And Miniforge is the equivalent. It's the non-bloated version that uses conda-forge as the default channel. So that's my recommendation, use Miniforge. And I don't know where the tip is later. Yes.
Bloated, does that mean it installs a lot of things by default?
Yes,
Or
that's
the
right.
actual core is
No,
bloated?
it installs many, many packages by default.
Yep.
And probably 80% you're never going to use.
Yep.
So yeah, it's especially, no, yeah. Here's tip number 1. Use Mamba. Mamba is a drop-in replacement for Conda that is fast. Whoever has used Conda before, sometimes, you type conda install, and then you go and grab a coffee, and then you go to the loo, and then you go back and it's still running. You're like, when is it going to be finished? Mamba is super fast. And you can install Mamba using Mini Mamba. Okay, so that's my final recommendation. Install Mini Mamba. And it also shows super meaningful information about conflict. So one of the questions that Ben asked in the Teams channel was, what the hell happens when I see this unresolved dependency weird stuff message, which spits out 150 lines of weird cryptic messages? That'll go away using Mamba. And here we go, demo number 1. We create a new environment using Mamba. So here's my little terminal. Let's create a conda create. -n gives the name. So it's a seminar. So my environment is going to be called seminar. And which packages do we want? We want Python, OpenCV, and PyTorch. And well, I just taught you to use Mamba, so let's use Mamba. Okay, so it downloads the latest packages there from somewhere. And now you see that I would call that quick to get all of those packages together that are the dependencies of PyTorch and whatever I just said. And now you can install it. Okay, so it's going to download 320 megabytes and install, create that new environment. So let's just do it, and we'll see what happens. So it's downloading all these packages now. It's downloading them all in parallel, which is a big change to Conda as well, which downloaded one by one. And then it's extracting them in parallel. So it's doing lots of cool stuff. And it's creating a completely new environment with, as you can see, quite a few dependencies that are dependencies of OpenCV and PyTorch. I think I just used. Yeah.
Why is this not default?
It will become default in some unspecified time.
Hey, Toby,
There's another cool thing. Okay, now let's.
There's got a question coming in from Peter.
Yes, Peter.
so it kind of
Oh, there you
makes
go.
me sad that there's multiple copies of all these things on your computer. So if you've got 20 environments and each one's got Python 3.8.1, is it downloaded and cloned in each one?
No, it's just symbolically linking
Okay,
to
perfect.
Python 3.8. Again, there's a disclaimer there. If one of the environments uses Python 3.8.2 and the other one Python 3.8.3, well, yes, then there's going to be two Python 3.8s around. But you can avoid that by cloning environments rather than recreating them from scratch every time, because those versions, they increase rapidly. Every day there's many new versions of all those toolboxes around, and you may or may not need them. But it's symbolically linked, so it doesn't, that they become big. So my Conda folders are gigabytes, but that's just the way it is. But yeah, it tries to avoid duplication as much as possible.
Thanks very much.
Now, while we are waiting for the installation of that, I want to show you something where, okay, which aims to address Ben's question. So I picked out a couple of two packages that are not compatible. And I know that because I looked at them. So Gazebo is like a robotics simulator, and Augur is some kind of graphics library. And Gazebo requires a specific version of Augur, which I looked up, so that's fine. But those versions are incompatible. So let's use Conda, which typically would happen, down the track. You already have 100 packages installed, and then you install this one additional package, which previously, would have gone to hell. I'm going to run this in the background because it's going to take a little while using Conda, and let's see what happens there. And in parallel, I'm going to try the same using Mamba, just to show you that the messages you get are much nicer if you use Mamba instead of Conda. So here we go. So Mamba is done. Mamba tells you, okay, package Gazebo requires Augur 1.10, but none of the providers can be installed because I asked for Augur 1.12. Okay, so it just tells me, I'm sorry, you're asking for conflicting package versions there. I can't resolve it. That's it. Do something about it. At least it's like a meaningful message. And here on Conda, it's going to tick for another while. I'm going to get back to it in a couple of minutes' time. In the meantime, whoops. In the meantime, okay, here we go. My environment has been created, and I can now activate that environment, but just saying Conda activate seminar. And now in here, we can go on and do further Mamba installs of our other favorite packages that we need in our daily lives. So that's the, yeah.
Toby, I can see that you previously were in RoboStack, and
Yes.
Does that install things on top of that environment, or have you created a completely new environment that has no cloning of that?
That's right. Yeah, I created a completely new one. I could have cloned it, but I didn't.
So you created
the environment using mamba, but you activated it using conda. Do I need to install conda first, then install mamba?
If you use the micro member, which I had in my slides, then you don't need to install conda first and then mamba. You can directly install mamba. And when I say use mamba instead of conda, there's one exception, which is you still need to say conda activate blah blah blah, not mamba activate. I don't know why they haven't done that yet, or they might. So that's the only exception. For everything else, mamba install, mamba uninstall, mamba, just conda activate. Yeah.
If you're switching from conda system to a member system, is comparative having conda
No.
and then you go to mamba?
No, you can swap as you like. Yeah.
Do they write to the same directory?
Yes. Yeah. Then drop in replacement completely.
So if you're sick of your work at the moment, you just use conda and walk away when you're setting up an environment, or you can use mamba and it will achieve the same thing, right?
Yeah,
That's basically
that's right. Yeah. Oh yeah, and here we go. So we have those. Where am I? I'm lost track in my environments. That's weird. Oh well, I'll get back to that. Sorry for that. That didn't show as nicely as I wanted, but trust me, if you use mamba, you'll get much more meaningful information. Let's go to tip number 2. Oh, sorry.
How does that relate to the system packages that are already installed? With conda always set up a clean environment that doesn't relate to the system packages?
That's right. Yeah. It lives in a parallel universe to your system environment.
Okay.
And I'll show you in a second. You should always use mamba for everything and rely the least amount possible on system packages. So whatever is available in conda, use conda for it. That's it. Always use mamba to install new packages. Don't use pip. Don't rely on your system packages. Do not mix channels. Previously, I said, oh, you can potentially. It results in all kinds of weird shit. Use conda-forge, which is the community-driven package, which has by far the most, the largest amount of packages and the most recent packages. So just use conda-forge.
You get angry about pip install inside the conda environment?
Last resort, okay? Like, please don't. Like, try to avoid as much as possible. If you need to use pip, 2 things. First one, install pip in your environment. Otherwise, it's using the system pip, and then it's weird stuff happens because all of a sudden you write in your global directory, which you want to avoid. And secondly, use pip with a flag called -- no dependencies to avoid that pip installs any dependencies and install the dependencies using mamba. So you avoid version conflicts.
What if you want to install a package from source or put a patch on a package or something like that?
I'll get to that in a little bit. Yeah.
Can I install CUDA?
Yes.
Oh, really?
Yes.
Nice.
Yes. Oh, right. To answer your question, if you manually need to compile a C++ package or Python something, install all the dependencies via mamba and install the compilers. So there's a package called compilers, which installs the latest version of GCC or Clang or whatever the standard compiler is. Install make, install CMake, install package config, install CUDA toolkit, and NVCC. And then you can run all of that from conda. Yeah. Tip number 3, you destroyed your environment. You've done something wrong. Shit, what happens? You can use conda list -- revisions to see all the commands that you have run since creating that environment. And you can roll back to specific points in time. So when you know it was all working fine at this time, you can roll back to that version and you don't need to worry, which is beautiful. Cool. What's hard with conda? So far, everything has been really nice. there are many packages, but not nearly as many as in Ubuntu or something like that. So if you rely on some not so common, not so popular package, it might not be available in Conda. And then you need to manually sit down and install the dependencies by hand and that kind of stuff, which is not fun, but possible. Things that are hard in your native system are hard with Conda. Whenever you use CUDA, it's always been a pain. It always will be a pain. Conda can't help you with that. You know, you still might need to apply some tips and tricks there, might have to play around with different CUDA toolkit versions and so on and so forth. It's just hard. Or Nico always likes to talk about OpenCV contrib packages with some random weird backends of some weird deep learning libraries. That's still going to be hard here, just because it's hard in general. It's not nicely packaged. It's still hard with Conda. And as a developer, if you want to bring your package on conda-forge, it might need some Conda-specific tweaks. But it can also help you to make it really nicely multi-platform compatible because it tests automatically on Windows, macOS, Linux, and so on and so forth, which you probably wouldn't in a normal case. And also, if it runs in one Conda environment, it runs in all of them. So if you run, Linux, you might always test with Ubuntu 18.04, and someone then comes along, uses 20.04, and it might just break. Whereas with Conda, it'll work, regardless of what your underlying system is.
How do they get around that?
It still builds multiple versions for Linux, OS X, and etc. But yeah. What's easy? Reproducible science. You can create those nice, equivalents to a requirements.txt file where you specify your dependencies, just in a much, much nicer way and more future-proof way. So you can go back to it in 2 years' time, still come up with the same set of packages, much, much nicer, and cross-platform as well. So you can pin down specific packages to specific versions, and other ones might be upgradable in those 2 years, because no one likes to still work with NumPy 0.9 from 10 years ago. Gavin, he likes, what is it, PyTorch 0.3 or something like that. So some of his coworkers use. It's super easy to create your a new channel with new packages. For example, in QCR, again, Gavin has those weird ROS, not weird, but has those parallel ROS packages somewhere lying around. And I guess it was a pain process to come up with the script in the first place. Conda makes it very easy. It does the cross-platform compilation for you, so you can build packages for your Raspberry Pi. You don't need to wait 4 hours and running out of memory 5 times. You can do it on your Linux machine or on online and continuous integration to build those packages. And you can add new packages to conda-forge. So, well, I've got 5 minutes or something like that. So let's just add Peter's ANSI table, which is a dependency for his robotics toolbox. And let's get it onto conda-forge. Let's try, okay? Okay, I should show you all of that. There's a thing called Grayskull, which auto-generates a recipe. And a recipe is basically a file that describes the dependencies of that package. That's only applicable if you want to put new packages on there. So that's like advanced thing. I just want to show that it's easy.
Under environment to a YML file and then commit. Is that standard practice, or is there a better way to do it?
There's a better way. If you read the link on Conda lock, click this link, and it'll tell you more on how to do it in a nice way. Awesome. Okay. So Grayskull. So Peter uploaded his ANSI table on PyPy, so you can pip install it, but currently you can't conda install it because it's not yet done. Okay. There's this conda recipe generator, and the project name is ANSI table. Now let's generate a recipe and see what happens. Okay, there we go. This is what a recipe looks like. So you have a name. Oh, it's really hard to read, eh? Should have tried that before. It did pull from PyPy, yeah. Well, just trust me. It has a name, it has a version. It's got a source from PyPy, which automatically pulls in specific name and the versions. It says it's a Python-only recipe. There's no C++ or whatever. It requires pip in Python, and to run it requires another thing called colored, which is already on Conda. And then we test it by just importing the package. And if we can import the package, we are happy. If we can't, oh gosh, something went wrong. And then it has like a very brief summary. Oh, we got it originally from GitHub, and it's a quick and easy display of tabular data. So it pulls all of that automatically. And then the only thing we need to change is we need to put a license file, and we need to say who is maintaining this recipe. So those are the only things we need to change. So let's copy this by clicking that link. And now we are on conda-forge. On conda-forge, there's a thing called staged recipes. So at the end of the day, there's going to be a repository called ANSI table, but we can't create that now. We need someone to confirm that we've done our job nicely, and then they're going to create this repository for us. So there's going to be a set of core developers who have the right to merge in and create this new repository. For now, all we need to do is, so here's an example recipe, and I'm going to create a new file, which is called ANSI table/meta.yaml. So that's the name of this file that we need to create. And I'm going to copy in all of that. And the maintainers, well, going to be selfish, going to put myself down there. And Peter's username is Peter Cork. Could have guessed that. And the license file, well, let's have a look in the repository. Oh, there's something wrong here.
Hey, Toby.
The license file is called license. Could have guessed that as well.
Yep. Toby, it's Peter.
Cool. And now we say create ANSI table package.
Toby, before you do that,
propose a new file. Yes, Peter.
There is an error in that in the metadata, which is that line there. It says BDSim. That should say ANSI table. That's an error in my setup.py file. I just noticed that.
Good. Good that you blame it on yourself rather than on me. Let me fix that in a second.
Sure. You're going to be the maintainer. All the grief will fall on you.
Create new package, and then we're going to create a pull request. And that's it. And now we can go in here, and we can make Peter happy by going into recipes, ANSI table, and fix up the mistake where it says somewhere BDSim fix. Cool. That's it. Now there's a new pull request, and there's an ANSI table package, and now it's basically, it says it's looking good. It's saying, oh, all recipes are excellent. So there's no problem with the recipe itself. Now you see here that it's queued to run to actually create that package. So if we had 5 more minutes, oh, okay, now there's a couple of, so it's creating the recipe now for Linux, OS X, and Windows automatically. We didn't do anything, right? We just copied the file. And the rest is being done for us. So that's super cool. And if you have, I'm running over. All of you, whoever needs to go out for lunch, please have lunch. And So that makes it super easy if you first put it on PyPy and then on Conda, but nothing stops you from linking directly to your GitHub. All you would need to change is, rather than saying, you know, the source doesn't come from PyPy anymore, but instead from a GitHub repository. So you can do it directly there. Another cool thing that I want to mention is that when you release a new version in your GitHub repository, it's going to create a pull request saying there's a new version available automatically. You don't need to do anything. And you just click merge, and the new version appears on conda-forge.
Can you give it a GitHub link, that Grayskull thing? Can you give it a GitHub link? Those are exclusive.
Grayskull is exclusively PyPy.
Okay.
Yeah. All right. So I've got a couple of nice slides to finish off. RoboStack. RoboStack brings ROS and Conda together. So if you ever wanted to have ROS and Python 3 and TensorFlow and OpenCV and blah, 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 in one package, it's always been a pain. Here with Conda, it's super easy. You just do mamba install, ROS Noetic, desktop, and that's it. And PyTorch and whatever you want. And it's going to install them all in one environment. It's on Linux, any Linux distribution, macOS, Windows, and ARM. You don't need root access, so you can run ROS on HPC now. Whether that's useful or not is a different question, but you can. And we faced unique challenges bringing it up. So we auto-generate those Conda packages from the package.xml. So you can just run in any package XML and creates that. And we use a different build script called Boa, which is a faster version of Conda build. So it just makes it super fast.
There's a question online. RoboStack, is this for any ROS distribution?
Just for ROS, Noetic, and Foxy at the moment. Nothing stops us from going different environments except full time.
Does it really work on Windows?
Yes. Yes,
Really?
it does. Yes. We've got, Arvis running on. I can show you Arvis here.
All right,
on my Mac.
I'll believe you.
Yeah, it runs. Now you can do really cool stuff. So Jupyter, it's a different talk, but it's this really nice development platform. And now we can run a Arvis-like thing in Jupyter. And we can change the join states just using sliders by installing Jupyter and ROS in the same environment. So now imagine developing that. It's like super cool, right? You can do standalone widgets. Gavin, he's written this nice graphical interface for the demos here in QCR. Probably took him, months, years, I don't know. Now, we can create those widgets, which just run in the browser, built from a Jupyter notebook. And we can, here we go, we can control a robot by saying, oh, go at a certain speed, go at, go in a certain direction. You can change it around. It's moving 2 meters forwards and at 0.5 degrees radians to the left. And you can build, many, many things using that super easily. And once QCR found money for a spot, we are ready for it. We can just do it. So, you can control the spot in the same way as any other robot using those beautiful interfaces. And that's it. Thank you very much.
Not over time, but are there any last questions from the audience?
Yeah, thank you. That was a really interesting talk, and I'm almost convinced to change everything to Conda. I just want to hear the dark side. What's the worst thing about working with Conda for you? The absolute most terrible thing.
Still like edge cases of trying to install PyTorch and TensorFlow in the same environment, which require weird versions of CUDA toolkit, and then trying to install some packages on top. So recently there was this PyTorch 3D package, and I just couldn't get it installed because They didn't have it on conda-forge, and manually it was just a pain because there's so many dependencies. So that's just hard, but it's inherently hard to package for any manager. So it's not like a fault of conda. It's just that it's hard to do in general.
Yeah. Any workflow for that application where you have to switch channels? So you get most from conda-forge, but then one package isn't on conda-forge. Can you
Yes.
get it from another channel without?
Yeah, there is. Yeah. So you have your if you look at your there's a conda RC file, which basically says, okay, those are my channels. So I always use RoboStack, which is like the ROS packages, conda-forge, and defaults. And then you say, have it by strict priority. So if packages are available in RoboStack, don't install the conda-forge or defaults one, and so on and so forth. So you can just put other channels down in the priority list and then install them from a different channel.
So if a menu say conda install -c this other channel,
Yes.
this one package, but then this one also has dependencies, would it then grab them from that third channel, or would it then default back to the fourth channels for the
I
dependencies?
don't want to say anything more, I'm not sure. But it shows you very nicely from which channel it would install the dependencies. I'm not entirely sure. Thanks.
If you're a lazy person and don't want to maintain anything, say for example with the answer table stuff, let's say you wanted to use it but you didn't want to maintain it on conda-forge. Is there a way of just doing it locally or no?
There is, but it's going to be harder than maintaining it on conda-forge. Just because you need to install all those weird things that are automatically installed if you do it here on your local machine, which is going to take you a little while. And then you need to figure out which commands survive in which directory and so on and so forth.
I was just wondering if there was a local recipe built.
There is, yes. So indeed, if you look at Linux, it failed. Oh my gosh, that's the worst. So if you look at a let's say the gazebo, the feed stock, which has like once the pull request has been merged, creates a new repository. So in this case, it's gazebo. And then if you look at the root, it has a build locally.py. So you just run this and then it builds it locally. But you need to have stuff installed. Cool.
Is there any way to make it like pass through to a different environment if it's not installed in the one environment? Because I have a lot of Python packages I need for my editor, and I don't want to install that in every different conda environment. So is there a way to make it like you install those in a separate environment and just make everything?
Yes, you can create this one environment where everything is installed, and then you can clone it from that one. If that makes sense. So
you have like a base environment, right?
Yes. Or you can create a environment.yaml file and then say install all the packages from that file. So those are the two options.
So if you're saying you have a couple of packages that you generally would use all the time, you would just build your base environment and then take a clone of that and start working off that?
We with everything except for calling it base environment, because base is base.
Okay.
Create a Nico base environment and then
On top of that, how big is that conda folder on your computer?
It hugely depends on, I don't know. Let's have a look.
How many packages you've installed, right?
Yeah, depends on the packages, how long.
So just as a thing, the GPU clusters, I had to go and delete the mini conda folder or like the environments folder because people who had left, their folders were like 30 gig, 40 gig.
Yeah, that can happen.
Okay.
So how big is it? I can't see.
It's still calculating.
So isolation always relies on some sort of bleed through, right? Like if I've got a dodgy, say I've got an NVIDIA driver that's useless, whatever I put on top of that's still not protected, right? On a higher level, how does conda protect from my system packages changing and all that sort of stuff?
So it packages just a lot of low-level packages itself. So it doesn't package your NVIDIA driver, but it packages CUDA toolkit by itself. So as long as your NVIDIA driver supports that particular version of CUDA toolkit, it all lives within the conda environment. So it protects itself by having a minimal set of things it's using from your system.
Is that easy to see? What it's using from my system at any time?
No, not that I know.
Cool.
So,
We'll make this the last question.
so that in turn means that there will at least be one duplication when I set up the environment. Like I have my system environment set up now, but then as soon as I go to Conda, I have to set up all those things once again at least, and then that copy exists there.
What do you mean by all those things?
So I have CUDA installed on my system.
Yes.
I have TensorFlow and all that's
That's fine.
installed on the system.
Yeah.
And as soon as I set up a Conda environment, it won't install the system.
That's fine. At some stage, you're going to forget about your system. Like, I never install anything on my system anymore.
Well, we're out of time. Thank you very much for talking to me. And everyone else. It's been fun.